Hey everybody, and today we're making a video on how LLM models learn. And this is a topic that comes up quite frequently. I see it come up all the time on online message boards, etc. I generally try to avoid the topic and avoid the debates because there's a lot of misconceptions and just a lot of bad information in general around this topic. And so it's not a topic that I like to discuss in general, but recently Anthropic did a study. And so what they did is they reverse engineered essentially an encoder. And then so if you're not familiar with LLM models, so let's start there. There's first of all, you have when an information goes through an LLM model, it's you have an encoder and a decoder. So the information is encoded, and then the information is decoded from there. So when the information is brought into the model, that's encoding. And then so kind of like how the information is stored in the model. And that's exactly what we're trying to access and understand within this, right? How exactly does the model store information? And then the first misconception that I hear around this a lot is people say that LLM models, they store information like, for example, like the same way that a hard drive does, or the same way that a computer program does, etc. And that's not true. Like they're not storing the actual information themselves. And then this is a very perfect example of proving that to you and showing that to you exactly how the LLM models do store information. And then the other thing I want to caveat and note before we dive into this is that this is very specifically for LLM models, right? And then so if we're talking about diffusion or other types of AI models, they learn differently than this, and there's like different elements that go into different AI models. Like AI is not a monolithic entity overall, right? And I think that's important to understand. And then so within this, when we're talking about learning, this isn't learning across the board, right? There's different types of learning, and then so uh, and I think that's important, right? Like that different types of learning, because would I say up front that this type of learning is the exact same way that you or I learn? And the answer is no. I don't think that. I think that there's a few differences, at least in this process, between the way that I learn and the way that like you learn and the way that an LLM model learns. I don't think it's that different though. Like that's the big thing overall, right? Like it's not huge differences. But so let's get into this. And then so you have over here a few different. You can see these scaling model semanticities, and I selected the nearest neighbors to Golden Gate Bridge feature, and then I could have selected different features, right? But then so this is related to the Golden Gate Bridge. And then, so within this, you can think of it like you have text, right? Like, and then so you have like a body of text, and it's been fed, like it's base text with regards towards the Golden Gate Bridge and how it works. And then within that, you have kind of connections to the Golden Gate Bridge. So San Francisco 49ers, San Jose area codes, California coastal fog answers, Monterey Bay area codes. All of this information and all of these concepts are tangentially related to Golden Gate Bridge and the Golden Gate Bridge. And then the Claude model in this instance, which it's modeling after, is encoding this information as the concepts, right? It's recording and encoding the concepts and the patterns. And that's the most interesting thing to keep in mind within this and to keep in light within this, is that it's encoding the patterns of information, and it's the patterns of information, and like that's the most important element within this, right? Like it's not encoding the information itself, it's not memorizing it, it's encoding the patterns. And then so within this you see patterns of similarity. So where we have Golden Gate Bridge, there's a similarity pattern between beaches and coastlines and the Golden Gate Bridge, of course. Same thing with neighborhood and district names, La Jolla and San Diego area codes. So we can see that it groups like San Diego and San Francisco together tangentially, and the Golden Gate Bridge, and then Monterey and California coastal fog and Bellingham, Washington. And then we can see all of these are tangentially related in Claude's mind, our neural network, to the Golden Gate Bridge. And then we can do another concept, right? Like here's Amelia Earhart. And then so we see that Amelia Earhart is here, and then tangentially related to Amelia Earhart is airplane crashes, of course, parachuting and skydiving, Marie Curie, historical explorers, Georgia O'Keeffe, seaplanes and flying boats, aircraft and space models, fighter pilot aces. So we can see all of these concepts become tangentially related to and closely related to Amelia Earhart in Claude's neural network. And then so again, it's patterns of information. It's the learning of these patterns of information, right? And like that's the big concept. And then so in general, the model is world building around textual information, right? And then so within that, I see like a lot of people also making these arguments around like model hallucinations and getting facts wrong and things like that. One thing that I'll highlight within this, and it's not directly noted within the recent Anthropic paper, but it's been noted previously a lot, is that within this process, the more that we scale up these models, like the smarter and the bigger that these models get, the more that they converge around information, right? They converge around facts, around the universe. And then so like Amelia Earhart would be a bad example of this. Let's see, of a good immunology might be good. So this is very like factual, right? So then we've got HIV diseases, things like that. And then so what immunity, and then so what we'll find within this is that the models will converge around disease, like the cause of disease. Like if you feed a bunch of huge LLM models, like the most advanced LLM models that you can, the most advanced data around diseases that you can, you'll find that they all start saying the same thing around diseases. And it's not just related to the data; it's related to the patterns of the data, right? And the fact that they're converging upon like the facts of the patterns within the data, and so all of this is very interesting overall to me, and just exploring to you how exactly the LLM models are learning and representing this information, because it's a lot different than a lot of people are saying. Right? It's like they're representing it the same way that you are in your mind. And then going back just on the last note as to why I said that I think that this is a different process than the way that you or I learn, right? I think that, and this is just my opinion, I think that the way that you or I store information is similar to this. Like I think that if we're talking about like immunology features, and then if I think of immunology features in my mind, then I have like inflammation as a concept next to that or near that, and then probably like immune functions, system functions, and like I think that my brain patterns information this way. Where I think that the human mind differs is with regards towards the way that the LLM models are getting at this information, and they're storing this information is a process called backpropagation, right? Where essentially you feed the model like prediction feed forward, and then you feed it back over the neurons and like back over the weights, and that's kind of what adjusts the weights as it goes back through that. I don't think that there's an equivalent of that in the human process. Like I don't think that that exists in our brains. I don't know how we learn, like how we get the information into these pattern areas, but I think it's different than the process that the LM model uses to get into these patterns. And then perhaps the patterns are the same. I don't think it's 100% the same. There's just got to be something different there, right? So overall, I do think that there's some similarities, probably, and most probably to the way that humans learn with regards towards this process. But I don't think that this process is any way at all exactly how humans learn. And I think there's interesting things to learn from that, right? Because we can learn from that and infer from that that learning is learning as a concept overall, and that there's not one type of learning. It's not human learning or no learning, or biological learning or no learning. And that's kind of what I think that we're uncovering with this, and kind of just what I'm trying to highlight and showcase here. And then so this is how LLM models learn. If you like this type of content, please like and subscribe. Thank you very much.